This conference will now be recorded.
Dear students, here we discuss about the implementation of interpolation and decimation by using MATLAB. What do you mean by interpolation and decimation? Decimation means reducing the sampling rate, that is number of samples per second. Similarly, interpolation means increasing the sampling rate. So how to get the decimation? Suppose if you want to get the decimation by a factor of m, from the original signal, we have to take only the zeroth sample, mth sample, 2m, 3m, 4m like this. Only we are considering we are taking mth sample and removing remaining samples. Like this, we can obtain the decimation by a factor of m. Similarly, interpolation by a factor of L can be obtained by inserting L minus 1 zeros between or L minus 1 samples between adjacent samples. So here is the program for the decimation as well as interpolation. So if you observe the instructions here, CLC, already we know that CLC means clear the command window, close all, closes all the previously open windows, and clear all clears previously stored values. Now first we have to generate the input sequence. For the input sequence, we have to select the input signal frequency here. Input signal frequency FM is equal to 10 and the sampling frequency Fs is equal to 140 and the time range is 0 to 0.5 in the interval of 1 by Fs. And the input signal here x is equal sin 2 pi fmt. Now we have to plot this input sequence by using subplot 4 comma 1 comma 1 stem x. For this sequence, we have to give the x label as number of samples, y label as amplitude, and title is input discrete sinusoidal sequence. Now, decimation of the input sequence by a factor m. Here, we have to select the factor m. Here, m is equal to 2. So xd is equal to decimate of x comma m. That is resample the sample the input sequence x with 1 by m times the original rate. After decimating, we have to plot the sample by using subplot 4 comma 1 comma 2 stem xt. Similarly, for this signal also we have to give the x label as number of samples, y label as amplitude, and title is decimated sinusoidal signal. So this is the decimated sinusoidal sequence. Similarly, the original sequence is interpolated by a factor of L is equal to 2 here. So we have selected L is equal to and xi is equal inter of x comma L. Here x is the original signal. So how to get this interpolation by a factor of 2? That is by inserting 2 minus 1 sample. 2 minus 1 means 1 sample between adjacent samples. You can get the interpolation by a factor of L is equal to 2. Now, after interpolating, we have to plot this interpolated signal by using subplot 4 comma 1 comma 3 stem xi, and for this x label is number of samples, y label is amplitude, and the title is interpolated sinusoidal sequence. So up to now we have decimated the original signal and interpolated the original sequence. Now if you interpolate the decimated sequence by the same factor, what will get? You will get the original sequence that we can observe by using the last one, that is interpolation of decimated signal. So we have already decimated the original sequence by a factor of 2. Now here we are interpolating the decimated sequence by a factor of L is equal to 2. That is by the same factor. So xi is equal inter xd comma L. That is we are interpolating the decimated signal by a factor of 2, and we are plotting the interpolation of decimated signal by using subplot 4 comma 1 comma 4 stem xi, and for this the x label is number of samples, y label amplitude, and title is original signal obtained after interpolation and decimated signal. Now I'm executing this program. Here you will get the figure window. In this figure, the first figure indicates the original input sequence, that is in discrete time sequence, and for this the second figure indicates the decimation by a factor of 2. So the original sequence is decimated by a factor of 2. So if you observe here, we are taking 0th sample, second sample, fourth sample, sixth sample, eighth sample, 10th sample, like this. And we are removing remaining samples. We are considering only the mth sample. Here m is equal to 2. And the next one is third figure indicates the interpolation by a factor of 2, the original signal. Here the original signal. So in this original signal, in between adjacent samples, we are inserting L minus 1. Here L is equal to 2. 2 minus 1 means 1 sample. So like this, by inserting 1 sample between 2 adjacent sample of original signal or original sequence, we can obtain the interpolation by a factor of 2. The figure third figure indicates the interpolation of the original sequence. Now, we will interpolate the decimated sequence. The second figure indicates the decimation by a factor of 2. Now, if you interpolate the second figure, that is the decimated sequence, by a factor of 2, what will get? So here, the fourth figure indicates the interpolation of decimated signal by the same factor 2. So how to get the interpolation by a 2? By inserting 2 minus 1, that is 1 sample between adjacent samples of this decimated sequence, we can obtain the interpolation by a factor of 2. Now if you observe the first figure, that is original signal, original sequence, as well as the last figure which indicates the sequence obtained interpolation as well as decimation, you can get the same sequence here. You can obtain the same original sequence. Thank you.